Example 3 is asking us to consider an arithmetic sequence with an explicit rule of Tn equals 4 plus 2n. The first question is asking us to prove it's arithmetic. First of all, we need to remind ourselves of what arithmetic actually means, and it means that there needs to be a constant common difference between each term. The other word that's important in this question is prove. If you want to use numerical examples, then really that is only a show question. So show that it's arithmetic, you would use numerical examples and show that the difference between the two is the same. With prove, you must use algebraic examples. To show you the difference, I will show you prove first and then I'll show you show afterwards. All right, so first of all, we'll do prove, and remember it is only using algebra, not specific examples. So we need to check the difference between Tn and the next consecutive term, which is Tn plus 1. So we want to find the difference between the two. So Tn plus 1 minus Tn will give us the difference between the two terms. Tn plus 1, just a reminder that Tn is 4 plus 2n. So Tn plus 1 is going to be 4 plus 2n plus 1. So where there was an n up here, there is now an n plus 1 because this is n plus 1. Then we subtract Tn, which is 4 plus 2n. Be careful with your brackets because you have to subtract the first term and the second term. Then we expand, collect like terms and simplify. So this is 4 plus 2n plus 2 minus 4 minus 2n. And you can see that the plus 4 minus 4 cancels each other out. The plus 2n minus 2n cancels each other out, and we're left with 2, which tells us that the difference between Tn and Tn plus 1 is constant and it's equal to 2. Therefore, the sequence is arithmetic. So why do we use Tn and Tn plus 1? Because what that means is we're talking about any term and the one straight after it. So any term is the Tn part, and the one straight after it is Tn plus 1. So you could be talking about the millionth term and the 1,000,001th term. So you've shown for any term and the one straight after it that the constant is 2. So that is a proof. I'll show you the difference now with a show, what show looks like if you're being asked to show. So if you're being asked to show, you can use numerical examples. And an obvious place to start would be to calculate T1, which is 4 plus 2 lots of 1, which is 6. T2, you can work out is 8. T3, you can work out is 10. T4, you can work out is 12. Then you can check. 12 minus 10 is 2. 10 minus 8 is 2. 8 minus 6 is 2. Therefore, consecutive terms have a common difference of 2 Therefore, you've shown it to be arithmetic. So what's the difference between these two? It's this bit here, and I'm going to spend some rainbow pen on it. It's the fact that we've for the proof, we've proven it for any term and the one straight after it. For the show, we've only considered In fact, that's not worthy of a rainbow pen. I want to do it in a red pen. We've only considered terms 1, 2, 3, and 4. We haven't shown it to be true for every single term and the one after it. We've only shown it to be true for the first 4 terms. So that's a show. The proof has to be true for every single term. So once we've shown that it's, or proven that it's arithmetic, we can find A and D. So A is T1, which is 4 plus 2 lots of 1, which we've just calculated before. And D, we've arrived at D in both our proof and our show, so D equals 2.